In this problem, we're looking at the number of advertisements that should be made on each of two websites. The two websites that we have, one of them is a medical parts supplier and the other is a fitness e-zine or e-zine, which is basically a web magazine. So we'll define our variables first. We'll say that let m, in this case, because we're looking for the number that should be of ads that should be placed, we'll let m equal number of ads on medical part supplier website, and we'll let f equal number of ads on the other website, the fitness e-zine. And we're given a few constraints here. We know how many hits they receive, which is not really a constraint right now, but we know that the daily cost to advertise is $1,100 per advertisement and $1,600 per advertisement respectively for the medical parts and the fitness. The director would like at least 15 ads and is able to allocate up to $50,000 for advertising. So at least 15 ads means that the total of all the ads should be greater than or equal to 15. And its budget is $50,000. Well, so for the number of medical part suppliers ads that it can make is $1,100 times m plus $1,600 plus f. That will give us the total amount of cost related to those two, but this must be no more than $50,000 because that's the full budget. Further, at least 3 ads should be placed on each website. So m is greater than or equal to 3, f is greater than or equal to 3. How many ads should be placed on each website to maximize? Okay, so we want to maximize, and the function that we want to maximize is the total number of readers, even if some of them are duplicates. So we know that the medical part supplier receives 1,200,000 hits per day. So we'll just do 1.2 times the number of ads, because we're assuming that all of the people will see those ads, plus 2.0 times f. Now that may be a bad assumption, but sometimes that's the best that we can do because we can't always keep track of all the pages that people visit. Okay, so what's this going to look like? Well, we'll let m represent our y variable. So m is greater than or equal to 15 minus f. This will allow us to get into our calculator. And now we have m is less than or equal to negative 1,600 f plus 50,000. And, oh sorry, this is 1,100 m. So we divide by 1,100, giving us negative 1,600 over 1,100 f plus 50,000 over 1,100. So now oops, extra 0 there. We have to be careful here because if m is our y value, then y equal to 3 is a horizontal line going this way. This would be m equals 3. F equals 3 would be going up and down. So basically our first quadrant has essentially moved to be up here because we need at least 3, at least 3. So we're dealing with this region here. 15 minus f, well that has an intercept of 15. And it will decrease by 1, so over here somewhere at 15 it'll cross again. So now we know that that has to be less than or equal to, oh sorry, greater than or equal to that, so now we're dealing with this region over here. Finally, we have this constraint here which is going to have a positive intercept. It's also going to decrease, and somehow it's going to cut through this region. Don't know exactly how. We'll plot that to see. So potentially we may have 1, 2, 3, 4 corner points. So now we're going to go ahead and graph this. And we're going to type in 15 minus x. And we're going to type in negative 1,600 divided by 1,100 times x. Oops, missing a 1 there. 1,100 times x. Plus 50,000 divided by 1,100. Now we're going to graph it. We know we're going to have to go at least up to 15. So let's just set our x-min. Well, we don't want to go below 3 because that's our minimum number of people, number of ads. And we'll probably go up to, let's just say, 100 for now. And we'll do the same thing here.